water going up or down as we squeeze the bottle? So, debate. What's going on? Is the water going up or down? Kayla's saying it's down. Marley's saying it's down. Kalia's saying it's down. Deshaun said the water is going up. What's going on? What's happening right now? Is it going down? Leah says it's going down. Okay. All right. Okay. So there's a little confusion. Some not confusion. There's a little debate about whether the water is going up or down. But even if, regardless of where the water is going, why is that happening? What's happening in the bottle, right? For squeezing on the bottle, what is the air doing to the water in the bottle? So go ahead and put in the chat. I want to see. Put in the chat. What is the air doing to the water in the bottle? I love the vocabulary terms. Jalea said that the air is compressing it, right? It's pushing it down, which leads us to our next question: is if the air is compressing it, is air powerful enough to do anything to the liquid? Do you think it's powerful enough to do that? Jalea's saying yes. Both Jaleas are saying yes. Thank you, Kalia. Marcus is saying yes. Yes, it is, right? Because it's doing what? It's compressing it now. So we actually did just investigate it. Probably I skipped a little too forward and said to see if our predictions were correct. And we did see what happened. So here's what to explain what happened. We're going to actually take a look at the word that's called volume. So can I have Tim, can you read for me the definition of volume? Yeah, Tim. We can't hear you, boss. Can you speak up a little bit? I need something wrong with your mic. No worries. Zamari, can you go ahead and read that definition for me? What does volume mean? Yeah, mute yourself, sweetie.
How much space something takes up.
Perfect, right? So we are looking at volume. The volume is how much space something takes up. And we're looking at and compared to the air that was in the bottle and also the water was in the bottle. We're going to actually take a look at the way that the air affected the volume inside of the bottle, all right? So we just looked at the video, and we saw that when we squeezed the bottle, that the water in the bottle was going down, versus a lot of people thought it was going to go out. So when the water was going down, what do you think was happening to the volume inside of the bottle? So is the volume inside the plastic jar greater, the same, or less when you squeeze it, based off of what we watched in our video? So is the volume inside the plastic jar greater, the same, or less? So I'm getting Marley saying, some people saying less, some people are saying the same. Okay. All right. Marley, why do you think it's less? Tell me why you think it's less. Come off mute for me, boss. Why do you think it's less? Because your response was less. Why do you think it's less?
I think it's less. Well, I said my answer, but I still explain why I thought that.
Okay.
I thought it was less because when you could press the bottle, I thought the air was going into the glass jar and pushing it down.
Okay, so you thought that the air was going in the jar and pushing it down. So does that mean that there's less volume in there, or there's more volume? Because we know that volume is how much space that something takes up. So is there more space being taken up, or is there less space being taken up? Or does it stay the same?
More.
Okay. So do you think there's more space now because you squeezed the bottle? Think about it. Did we add anything or did we take anything out? Zamari, help him out a little bit.
The same.
Okay, I said it was the same because it don't come out. It don't come out. It's trapped and it's compressed, so it gets closer.
I love the vocabulary. Right. So, like she said, it doesn't change. Right. Nothing changes inside of the bottle. It just compresses. Right. So we know that compression is when air particles are moving closer together. So when you think about it, the particles in the airs, can they be pushed closer together? And Zamari kind of answered our question for us, but go ahead and tell me, can they be pushed together? Go ahead and put it in the chat, even though Zamari answered. Let's see who's paying attention. Think about it, right? So we said that the volume inside the plastic jar stayed the same, right? Because we didn't add any air to it. We didn't take any air out. All we did was compress the air. So if we compressed it, the particles in the jar are doing what? What are they doing in the jar? Are they moving farther away or are they moving closer together? I should be seeing a bunch of answers in the chat because Zamari actually just answered it for us. And since we all know what compression means, I know we do because we actually took a test or CFU, which we did amazing on, which I'm going to share those results with you guys on Friday. But we should all know what compression means. And if it's being compressed, then what's happening to the air particles in the jar? Thank you, Jakayla. Thank you, Zamari. Still waiting on some responses from Blake, Kevin, Nazim. Thank you, Kalia. Still waiting on response from Markel, Miss Henley, Kyra. Should be seeing a lot of participation right now because it's giving out the answer, right? And exactly, they are moving closer together because the air particles are being compressed. All right. So, how does squeezing the jar push the particles closer together, right? So, what is happening? How is squeezing the jar push the particles closer together? What's happening? What are we doing? Okay. Should be seeing some responses in the chat. Thank you, Marley. Right? He's using. I love how he's using vocabulary terms. Right? We're using definitions and vocab terms that we've been learning. And again, let's make sure that we are using our notes catcher. So our next question is, how did the air particles interact with the water in the bottle as you compress the jar? Why does the water in the tube go down when you push it on the side of the plastic jar? Also type that in the chat. And I want you guys to take the next 5 minutes to answer these questions and also work on your notes catcher, okay? And while you guys are working on that notes catcher for the next 5 minutes, what I'm going to do is I'm going to show you the video one more time so we can take a look at the jar, right? So we can see what's actually happening inside the jar, all right? Skip this because this lady was moving kind of slow with her hands. All right. So right now, we're filling out our notes catcher. We're going to take a look at what's happening inside the bottle again. All right, right. So the bottle is, we have the bottle, the water inside of the jar, and we're squeezing the bottle, right? So as we squeeze the bottle, we notice that the water in the tube is going down. You see the water in the tube going down as you squeeze the bottle. As you saw, we had the water bottle. We saw that it was pushing down, and we were squeezing the bottle together and pushing it down, okay? So while we're working on that nose catcher, I know we should be around finished with that. A few questions left. Give you about 1 more minute. So, when the jar is squeezed, the volume in the jar is what? The particles are moving closer together or farther apart, so they can bump into each other more. So what is happening? Are they moving closer together or farther apart? And could I have a volunteer go ahead and share that with the class? Are they moving closer together or farther apart? Go ahead, Ms. Bailey.
The air particles are moving closer together.
Bang, they're moving closer together because they are doing what? They are compressing, right? So we know that when the air particles compress, and we know that they're compressing because when we squeeze the bottle, the water is going down, right? Since it's going down, it means that the water is moving closer and closer down versus going out, right? So what would have happened? What would be considered if the water would have came out of the bottle? What would have happened? Because we know that compressing means that the water is shrinking, but if it would have moved further out, what would have been called then? That's a little bonus question. I know that's not in our notes, but let's see if we can recall some of the things we learned from last investigation. Deshaun, do you know what it would be called? If we know that things moving closer together is considered compression, what would it be called if it's moving further apart? Go ahead, Kalia. You got the answer. Look, y'all even got Mr. Ben Gore making sure he knows.
Wait, what you say again for the question?
We know that the particles, an example that we saw where the water was going down, we knew that it was moving closer together, right? So if the water would have been coming out instead of going down, what would it have been called then?
It would have been called expanding.
Exactly. It would have been expanding, right? Because we know that when things move further out, that is expansion. But when they're going closer together, that is what we call compression. So when we're doing this, we talked about what pressure means, and we know that pressure is the amount of force that is on a given surface. By compressing and by watching the water go down, we are increasing the pressure in the jar. We are increasing the pressure in the jar. So can I have Marley, go ahead and read that explanation for me up there.
The air inside the top of a clear tube almost compressed. The compressed air pushes down with more pressure on the top of the water. This pressure pushes the water down the tube.
Thank you. So when we saw, like we saw in the video, right? The water was going down because it's being compressed, right? So when we're compressing the compressed air, like we talked about before, is what makes the water shrink closer and closer together. That is what's pressing it down versus pressing out, right? So to clarify a misconception, because a lot of us thought that if we squeezed the jar, the water would have came out or expanded out. Many people think that when the jar is squeezed, the water will come out. However, applied pressure condenses or compresses air particles into smaller space down the tube so that the water goes down instead of